Hello, class, and this week we will begin Chapter 10. We're only going to do a little bit this week, and we'll do kind of the bulk of Chapter 10 next week, just because I want you guys mostly to be focusing on your projects. But Chapter 10 is probably one of the most relevant concepts we're going to be talking about for everyday life, and I wanted to get into the basics of mathematical finance. So, in this chapter, we're going to talk a little bit about debt, savings, and obviously focusing on the math behind those sorts of formulas. So, say for example, you want to take out a loan, and you want to figure out, well, what does the interest rate mean? How much am I going to be paying, and what are the implications of that loan? We're going to be examining that this chapter. Or say we want to save our money in the form of retirement savings. How can we understand how that's working? Because there, and let's just get into the slides. But obviously, finance is something that pretty much all of us have to worry about at some point in our life, and it's something that's not really taught very often in math class. Um, so, anyways, let's just get. I'm going to walk through the slides for a minute, and then we'll work on the packet as we go into some examples. But for this week, we're just going to do 10.1 only, and next week we will get into interest and amortization. But wanted to start off with some statistics, and you know what this how the saying goes. 50% of all statistics are made up on the spot, which actually I just made up also. But these are actually were from the book, and I thought that they were quite interesting statistics. These might be a couple years outdated, but 64% of Americans do not understand how compound interest works. 82% of American college students with credit cards don't pay their full balance every month, resulting in interest. 34% of Americans do not have any retirement savings, and 27% have no personal savings. So, just examining these numbers, it can be quite startling the number of people who don't have very good financial background, who don't really understand the mathematics behind interest, who don't pay off their credit cards or pay unnecessary interest amounts, or basically who have no savings. Now, obviously, sometimes having no savings or might be beyond our control, and that's what a lot of people think. But I think some of these problems are as a result of poor education, not really understanding how debt works. And that's kind of our main goal for this chapter, is to really understand the math behind interest and debt. Because I think a lot of people who are scared of debt or who fear loans and interest and those sorts of things, might the fear might stem from not really understanding what you're up against. Like for example, if you have a student loan, which a fair few students from Point Loma do have, some students I've talked to kind of are a little worried about their debt. They kind of have this pit of despair going in them regarding their student loan debt. But I think that just kind of understanding it helps. Maybe this is different. Maybe understanding it might make it worse for some of you guys. But anyways, that's kind of our goal. And a lot of the math in these chapters involve percentages or interest rates. So, for example, student loan may have a 6% interest rate or a 4% interest rate or 10% interest rate, kind of depending. Well, right now, due to the virus, student loan interest has been suspended, but that will resume at some point in the future, assuming that's my assumption. But anyways, just kind of referring back to percentage, I'm sure you guys know, but the percent sign, percent kind of literally means per 100, which is kind of how we define a percentage. And so one thing that you could think about is, mathematically speaking, a percentage number is not like a base number. And when you use a percentage number in a mathematical formula, typically you need to make sure it is plugged in not as its percentage form, but as its decimal form. Basically, we need to, as you probably remember, move the decimal place twice to make sure it is in decimal form. Or in a calculator, you could take the raw percentage number and just divide it by 100, which would be fine. So, for example, say we had something like 8.5%. If we're going to be plugging this interest rate into a mathematical formula, almost never do we want to plug it in as 8.5. That will almost always give us a horribly wrong answer, because really what 8.5% means in its value is it's not, it's 8.5 out of 100, and that's the number we